First we'll start with circuit making. We'll go to library. So here we have all the necessary components to prepare a power circuit of inverter, a single phase inverter. So now let me connect the circuit. So here our power circuit is ready. Supply voltage is 100 volt and load is of 50 ohm. Now in first method we'll give simply square wave like this using pulse generator. So let's prepare circuit for that. We'll use pulse generator. We'll open it. Amplitude will be 1, period will be 0.02 second, pulse width would be 50%. That means for 50% of this much of time it will be on, and for the 50% it will be off. So it will be on for 0.01 second and it will be off for 0.01 second. Okay, so this is PG1 and we'll connect this PG1 with the switch S1. Now we'll duplicate it. It will be PG2 and that will be for switch number 2. In inverter, the two cross leg switches are working together, switch 1 and switch 3 for positive half cycle and switch 2 and switch 4 for the negative half cycle. So using this pulse generator 2, we'll be producing pulses for switch number 2 and 4. We'll open it. Period and rest of the things will remain same, but delay will be 0.01 second. Now using this from block, we'll take input directly from this pulse generator. Now we'll tag this as switch number 1. You can give any tag as of your choice, but here I am giving all the tag as switch number, and here we should give it as. So here we have given S1, S2. We'll take two more, go to blocks. So here we have all the 4 blocks ready. Our pulse generator is ready. We'll reduce the operation time, simulation time, save it, and now before running we'll take one power GUI block. This power GUI block is always important while we doing any simulation in SimCaps. Even to observe both these pulses, we'll take one scope over here. Now let's run the simulation. We'll make it so now you can see for positive half this is working and for negative half the another switch is working. And let's see the output of inverter. So here you can see the yellow waveform is of current and the blue waveform is of voltage. So it is alternating in nature and converting DC into AC. Now let's suppose instead of this type of full square wave signal to this inverter, what if we can give a PWM signal to this inverter? So how to give this type of PWM signal to this inverter, we'll see in this section. So now we'll prepare a control circuit which produces PWM signal for this inverter. We'll add this constant block, then we'll add a repeating sequence, and to compare both of these signals we want a relational operator, and finally to have signal for particular time we'll add a logical operator. We want to have scope. So now we have almost all the components to produce PWM signal. So now I'm going to prepare circuit for that. So now here our circuit is ready. In this constant block we are giving a constant magnitude of 1, and in this repeating sequence we are going to generate a triangular wave of magnitude 2. These are the time values to provide a 20 triangular signal in 0.02 second. Why I did this, I'll tell you later on. So using this combination, I'm going to compare this constant block with this triangular and going to produce a pulses. Let's see that thing. So here I have pulses. I am comparing this triangular wave with this constant signal and getting this type of pulses. But here the question is, all these pulses are constant. But what I want to have pulses for these two switches from 0 to 0.01 second and pulses for these two switches from 0.01 to 0.02 second. So in order to achieve that thing, we'll use these two pulse generators. Pulse generator 3, what we'll do, we'll compare these pulses with this PWM signal to get output in only and only positive half cycle. So let me show you that thing. So now you can see here that we are getting pulses for 0 to 0.01 second, and for the other half cycle we are not getting any pulses. The same way to produce signals for S2 and S4 switch, what we'll do, we'll take this pulses and compare it with this PWM signal. So here you can see we are getting pulses for positive half cycle and pulses for negative half cycle. So we have updated from and go to port names, and now let's run the circuit. So these are the pulses for the switch. Now we'll see the output of inverter. So here you can see the pulses in output voltage as well as current. The blue one is output voltage and the yellow one is output current. So this is how you can produce PWM output in inverter. Now here, just by controlling the magnitude of this constant block, you can adjust the width of the pulses. Now just imagine, what if you want to produce SPWM signal instead of this type of PWM signals. So to achieve SPWM signals like this, let's prepare the control circuit. Sources will take sine wave, will take repeating sequence, will take scope, relational operator. So using these blocks, now I'm going to prepare a control logic to produce SPWM signal. In the sine wave block, the amplitude is 1 and the frequency is 2 pi 50 radian per second. That will give us a 50 Hz cycle of sine wave. Now the next thing is repeating sequence block, and here the same block I have used which we have used earlier. The second is comparator block, and here I have added two go to block and I have updated the name as SSS1 and SSS3. Now I will replicate the same circuit to produce SPWM pulses for S2 and S4 switch. Here in sine wave block, what we need to do, we need to provide a delay of 180 degree. So to create that delay, we'll write it as pi. Pi means 180 degree. So here we have provided 180 degree of phase delay. Now we'll update these names SSS2. The same thing I will update over here also. So I have updated all the from blocks and all the go to blocks. Now let's run the circuit. And first we'll check these. So here for first cycle, you can see we are getting SPWM pulses. The width at the beginning is very less, and as we approach to the center part of the signal, the width will increase. So this is the SPWM signals we are getting for positive half cycle, and here are the another SPWM signals that we'll get for negative half cycle. So these are the signals for negative half cycle. And now we'll see the output of inverter. So here is the output. So this is the voltage waveform, and the yellow one will be the current waveform. So this is how, using these three methods, you can generate pulses for the inverter.